Okay, continuing in this chapter involving, we're going to move on and talk about linear equations. Now, a linear equation in two variables is of the form, I'm going to give you this form, y equals mx plus b, where m actually represents the slope of the line, and b is the y value of the y-intercept. This is another way when you're working with polynomials, maybe in higher mathematics, they might write it like this, but we're going to focus on the form y equals mx plus b. Let's talk a little bit about the slope of a line. The slope of a line is actually a measure of the steepness of a line. So if the slope of the line is positive, then the line increases from left to right. So you can see here we have a positive slope, and as you go left to right, the y values increase as you move left to right. Now if the slope of the line is negative, then the line decreases from left to right. So right here you have a negative slope. Notice how the line decreases as you move left to right. And then if the slope of a line is 0, then the line is actually a horizontal line because it doesn't rise or fall. So here is a horizontal line, and that line would have a slope of 0. And then the other thing I want to mention is if the slope of a line is undefined, then the line is a vertical line. So here you have a vertical line, and so therefore the slope for that line would be undefined. Now, let's examine slope a little closer. So let's say that the slope of a line is 1/3. Okay? Well, that means for every rise in the y values, the x values would increase by 3. So if you notice, let me just highlight 2 points here. This point here and this point here. So if you'll notice, to get from this point to this point, you actually have to rise 1 unit and then move to the right 3 units. So the ratio of the rise to the run, and that's what slope is the ratio of rise to run, is 1 to 3. Now, here the ratio of rise to run is 1. So the slope is 1 in this case. And so here you would rise 1 unit and then run 1 unit. And so the ratio would be 1/1. Now on this one has a slope of 10, and you can see that when the slope increases like that, the graph will increase at a very fast rate. In other words, it'll be very steep. And of course, if you have a large negative slope, then the graph will be steep, but in the opposite direction. It'll be a decreasing graph, but yet it will still have a steep slope if you have a large negative slope. Now I put large in quotes there because technically -10 is not larger than, say, -2, but I'm really just talking about the magnitude of the slope when I say large negative slope. So anyway, that's just a little quick examination of slope. Now the informal definition of slope is actually the slope of a line is actually the ratio of the change in the y values over to the change in the x values. Now some texts call this delta y over delta x. Others refer to it as rise over run. So in here I'll just refer to it as rise over run. Now the formal definition of a slope actually gives us a formula for the slope. If you know that a line contains 2 points, like if you know the line contains this point x1, y1, and contains the point x2, y2, then you can actually find the slope of the line using this formula. And we use the little number m for the slope of a line, the little letter m for the slope of the line. So the slope of the line would be the y2 minus y1, so the y value, second y value minus the first y value, divided by x2 minus x1, the second x value minus the first x value. Now you could reverse these, but if you reverse the on top, then you have to reverse the one on bottom. So you could certainly do the first y value minus the second y value, but if you do that, you got to do the first x value minus the second x value, otherwise, or you get the sign wrong. So let me show you how to apply this formula here using these points. So here you have -2, 4, and here you have 2, 8. So let's find the slope of the line that contains these 2 points. So if we take the second y value, which is 8, and subtract the first y value, which is 4, that will give us the numerator. And then if we take the second x value, which is 2, and subtract the first y value, which is -2, then you're going to have 2 minus -2, so that's going to be 2 plus 2, which is 4. So you're going to have 4 for the numerator and 4 for the denominator. So 4 over 4 would equal 1. So the slope in that case would simply be 1. Alright, now let's look at this next one. If I take the second y value, which is 5, minus the first y value, -3, that gives me my numerator. And then I take the second x value minus the first x value, 4 minus 1, that gives me my denominator. Well, the numerator is going to be 5 plus 3, which is 8, and the denominator is going to be 4 minus 1, which is 3. So the slope there, the slope of the line containing those points would be 8/3. And then look at this one. If I take the second y value minus the first y value, I get 5 minus 5, which is 0. And if I take the second x value minus the first x value, I get 7 minus 3, which is 4. So in this case, I get 0 over 4, so the slope is 0. So if you plotted these points, you would find that these points contain a horizontal line. And then the next one here, if I take 3 minus -2, that's going to be 3 plus 2, which is 5. But then the difference of the x values is 1 minus 1, which is 0. And since you can't divide by 0, then that would mean the slope is actually undefined. And so the difference is if you plotted the line that goes through these 2 points, you would get a vertical line, whereas if you plotted the line that goes through these 2 points, you would get a horizontal line. Okay, I referred to this earlier, but actually this has a name. This y equal mx plus b has a name. It's called the slope-intercept form of a line, where the coefficient of the x value is the slope of the line, and the b value is the y value of the y-intercept. Of course, if it's the y-intercept, the x value would be 0. Okay, so if you want to find the slope and y-intercept point for this line, then it's easy. The coefficient of x is going to be the slope, so the slope is -3/2, and then the y-intercept would be 4, which corresponds to the point 0, 4. So that's the slope and y-intercept there. Okay, here's another one. The coefficient of x here is 2, and so the slope would be 2, and the y-intercept here would be -3, or the point 0, -3. And then here, since there's actually no x value here, so you can think of the coefficient of x as 0, so that means we have a slope of 0, but we do have a y-intercept here, -1, so it crosses the y-axis at the point 0, -1. Okay? Now, here's another form that a line might be written. It might be written in the form of ax plus by equals c, where a, b, and c are just numbers. So let's see if we can identify the slope if I'm given the lines in this form. So let's say I'm given the line 2x minus 3y equal 12. Well, one way to find the slope is just to rewrite this in the slope-intercept form. So that means I have to solve it for y. So to solve this for y, I would subtract 2x from both sides, and so I'd get minus 3y equals minus 2x plus 12. And then you would divide each term by -3 to isolate the y, so I'd get y equals -2 divided by -3x plus 12 divided by -3. And -2 divided by -3 would actually be a positive, so I've got that a typo there, so that should be a positive 2/3. So let's get rid of that negative. Okay, so there we go. Not a big deal, but you know, obviously you got to get the signs right. So the slope here would be 2/3, and then 12 divided by -3 would be -4, and so the y-intercept would be -4, or the b value is -4. Up here I gave you the point, and down here I'm just giving you the y value of the y-intercept. Okay, let's do it again for this one. This one, if I solve for y, I would get 5y equals minus x plus 3, and then divide everything by 5, and I get minus x divided by 5 plus 3/5. And then if I can actually write this as -1/5 times x. That way you can see that the slope here is actually -1/5. So there's the slope, -1/5, and the y-intercept is b equal 3/5. And then this one, if you solve this one for y, you get minus 3y equals minus 2x. And then if you divide both sides by -3, you get y equal -2 divided by -3x, which would be positive 2/3. So that gives me 2/3. So the slope here would be 2/3. But since there's no constant added out here, we can just pretend like it just says plus 0, and therefore the y-intercept would be at the origin, or it'd be the point 0, 0. One other thing you might want to do, here I was converting each of these from their standard form to the slope-intercept form. At times it might be convenient to convert from the slope-intercept form to the standard form. And usually what I do if I have a fraction is the first thing I do is I eliminate the fraction by multiplying each term by the denominator. So here the denominator is 2. So if I multiply each of these terms by 2, it will eliminate the denominator. So 2 times y would go there, and then 2 times this fraction would go here, and then 2 times 4 here. And then of course what's helpful is these 2's cancel, and that just becomes -3x. And then 2 times 4 is 8. So I get 2y equals minus 3x plus 8. And then you just simply move this term to the left and change its sign, and you get the standard form for the equation of that line, 3x plus 2y equals 8. Okay, that pretty much wraps up this video, and in the next video I'm going to talk to you about how we can use some of this information we learned previously in order to graph lines.